as the name suggests, we're going to look at chords of the parabola. So a chord, just like we have in a circle, and I guess that's where we're more used to seeing the word chord, but it means exactly the same thing. It's just an interval that starts and finishes on the boundary of the shape. So if I've got a parabola, I can join one point, and I'll give it parametric coordinates 2AP, AP squared, and another one which I'll call 2AQ, AQ squared, so the parameter of the first one being P, parameter of the second one being Q. So the blue line joining them would be a chord of the parabola. So how do we find this equation? Well, just like we do any line. We need a point, well, we've got two of those. We need a slope. Slope equals y2 minus y1 over x2 minus x1. Again, that comes back to all that work we did on algebraic fractions earlier in the year. You might even recognise this fraction from one of the exercises, and this is probably why. So we always factorise first. So p squared minus q squared, difference of two squares, cancels with the p minus q at the bottom of the fraction, and we get something interesting there. The slope of a chord is always the average of the parameters. So the slope of the chord is always the average of the parameters, p plus q on 2.
Oh, wow.
So let's put that into our formula. Y minus y1, slope x minus x1. Expand out. What do we got? We've got the 2AP squareds on both sides. That'll cancel. I end up with, and this is where I guess we tend to be a little bit hypocritical. You know how we've drummed into you, equation of a line. You always write it either as general form, so it all equals 0, or we make y the subject. And so, of course, here we are, and I'm not doing either. But that tends to be how we quote the equation of the chord. So p plus qx minus 2y is 2apq. Now, this always brings up the question, can you quote that, or do you have to derive that? Read the question carefully. Now, if it said, write down the equation of the chord, well, I can just quote it, I'm writing it down. If they say, find the equation of the chord, then they want you to work it out, because they're saying, go find it. Okay? Focal chord. Now, focal chord is a very special chord. As the name suggests, it passes through the focus of the parabola. Okay? So, again, let's draw up our picture. This time we know it's passing through the focus, naught A. If you see a focal chord question, probably somewhere in the question it's going to get you to prove a relationship between P and Q. So what I would do, I'm not going to redo it, we just did it in the last example. I'd find the slope of PQ, so remember average of the parameters. But then I'd find the slope of PS, which is, it turns out to be p squared minus 1 on 2p. Because PS and PQ are the same line. So those slopes must be equal. So if PQ is indeed a focal chord, those slopes would be equal. And then I could equate these two, and I come up with a simple little relationship. PQ is equal to minus 1. So the product of the parameters is -1. That's going to become quite significant later on when we look at some other stuff, that little relationship. Again, can you quote it? Once again, depends on the question. A lot of times they might be asking you to prove it. I would tend to go with this is one we'd want to prove, unless they specifically say write it down. I would always be proving this one. Another way I could have done, say we'd already worked out the equation of the chord, like we did in the first one, then it's probably quicker to simply say, oh, well, hang on, if the focus is on this line, it must satisfy the equation. So I'll sub it into our equation of the chord, and there we go, we just get PQ is -1 straight away. Because x is 0, the p plus q disappears, I get minus 2a is 2apq, PQ is -1. So I guess it really depends what else we've done in the question already. So the exercise bounces in, 9E.